Welcome, students. Today we're going to talk about the square root property. Now, a couple of weeks ago, we were solving quadratic equations, and the way that we did that was by factoring and then using the zero factor property. However, not every quadratic equation can be solved this way. For example, let's consider 2x squared minus 7 equals 0. Here, there's no greatest common factor that can be pulled out, so we look at the fact that there are two terms, and the only way that we can factor a binomial is if it's a difference of squares. However, this is not a difference of squares because neither of the terms is a perfect square. So unfortunately, factoring fails us as a method of solving this equation. However, that doesn't mean that there's not a solution. It just means that we need to learn a new tool, and that tool is going to be the square root property. So this is our eventual goal, to solve things like that. But for right now, I want to look at a very basic example. Let's solve x squared equals 16. Now, there's one thing that students will sometimes do when they're solving an equation like this without being told they're able to do it, and it ends up causing a problem. Students might see the x squared and think, oh, to get from x squared to x, I can just take the square root. So they try to take the square root of both sides. The square root of x squared, they get x. The square root of 16 is 4. And they think, okay, I'm done. Everything is good. However, this isn't quite right. What I want to do is I want to solve this using the method that we've been using the whole time. We need to get all of the terms onto the same side, and then factor, and then set each factor equal to 0. Let's do that. We subtract 16 from both sides to get all the terms on the left, giving us x squared minus 16 equals 0. And now this is a polynomial that can be factored. It's a difference of squares, and so it factors into x plus 4 times x minus 4 equals 0. Once we've done that, we can use the zero factor property and set each individual factor equal to 0. So x plus 4 equals 0, or x minus 4 equals 0. And then we can solve each of these equations. In the first one, we end up with x equals negative 4. And in the second one, we end up with x equals positive 4. So we know that in actuality, there are two solutions, x equals negative 4 or x equals positive 4. But if we look at this method that a student tried to use before, they only got one of the solutions. They got positive 4, but they didn't get negative 4. Now, this method that they tried to use, we can modify it so that it works and that we get both of the solutions. But what we need to do is we need to recognize that there are two square roots of 16, positive 4 and negative 4. And the way that we're going to account for this is by putting a new symbol in front of the 4. This symbol is called plus or minus. It can also be called positive or negative. It depends on the situation, and we will see situations for both of these. But here, when we write x equals positive or negative 4, this means that x is allowed to be positive 4. It can also be negative 4. So this is a way for us to account for the two different solutions. And the square root property says that whenever we take the square roots of both sides of an equation, we must account for that. Let's look at the square root property. The square root property says that we may take the square root of both sides of an equation. However, we must use a plus or minus sign to account for both square roots. That's the square root property in words. If we wanted to write it algebraically, we could write if x squared equals some constant, then taking the square root gives us x equals plus or minus the square root of that constant. Let's do some examples together. Let's solve x squared equals 36. Now here we have something in the form x squared equals a constant, so we can use the square root property and take the square root of both sides. On the left-hand side, the square root of x squared is x. On the right-hand side, the square root of 36 is 6. However, we have to remember that it's really plus or minus 6. There are two square roots of 36, positive 6 and negative 6, and so those are our solutions. If you're using WebAssign and you need to enter solutions there, WebAssign doesn't use a plus or minus symbol. It will ask you to enter the solutions as a comma-separated list, so you would write 6, negative 6, listing the individual solutions. Let's do a couple more. Let's solve 5x squared equals 15. Now, we're not going to want to do this exactly the same way as the last one, by just taking the square roots of both sides. And the reason is the left-hand side isn't a perfect square. X squared is, but 5x squared isn't. So we want to make sure that we have a perfect square before we use the square root property. And the way to do that simply is to divide by 5. That gets rid of the 5 and leaves the x squared by itself, giving us x squared equals 3. And now we can apply the square root property. The square root of x squared is x, and then on the right we have plus or minus. And because we need to take the square root of 3, and that's not a perfect square, we just write the square root of 3. So we end up with x equals plus or minus the square root of 3. And now we'll work on the original problem that we had written, 2x squared minus 7 equals 0. Again, to use the square root property, we need the left-hand side to be a perfect square. And in this case, it's not. So we need to start by isolating that perfect square. To do that, we can add 7 to both sides. That leaves us with 2x squared equals 7. And then we can divide both sides by 2. This gives us x squared equals 7/2. I'm going to rewrite this up here just so I have a little bit more room. Now that we have something squared equals a constant, we can use the square root property. The square root of x squared is x, and the square root of 7/2, we're going to write plus or minus root 7/2. But we have a problem. We're not allowed to leave our answer with a fraction in the radical. So what we're going to do is we're going to split that up into root 7 over root 2. And then we're going to rationalize the denominator. What can we multiply the top and bottom by so that the bottom becomes a perfect square under that radical, and we can get rid of the radical? Well, the answer is root 2. When we do that, we end up with plus or minus root 14 in the numerator, and root 2 times root 2 is root 4, which is just 2. So in the end, we have our final answer, x equals plus or minus the square root of 14 over 2.